Welcome viewers. Today we'll see the Coulomb's law. The Coulomb states that the electric charges produce the mechanical force on each other. If the two charges are placed at a distance, then force will be developed on each other. The expression for this force and characteristics was given by the Coulomb's law. First we'll see the characteristics. The like charges repel each other, but unlike charges attract each other. First point. Second one, the force is proportional to the product of the magnitude of the charges. If the two charges are available, mean the force will be proportional to Q1 and Q2. The third point, the force is inversely proportional to square of the distance between the two charges. 1 divided by r square, right? Inversely proportional to square of the distance between the charges. The force depends upon the medium in which the charges are located. Where the charge is located depends upon the medium it will act. And the last one is the force is always act along the straight line joining the 2 point charges. It will always act along the straight line. So these 5 points are given by the Coulombs, these 5 characteristics. Based on that we can go for the derivation. We'll see the diagram. So there are two charges available, Q1 and Q2. Q1 is placed at point 1, Q2 is placed at point 2. This R12 is the distance vector between Q1 and Q2. A12 is the unit vector. This F1 is the force developed on the charge 1 due to second charge. Similarly, the F2 is the force developed on Q2 due to the first charge. See the direction, both are equal but in opposite direction, right? So the expression for this force will be given by the Coulombs. Before that we'll see the unit vector. Unit vector is nothing but vector by scalar. The general formula is vector by scalar. It can be expressed in two ways, in terms of force or in terms of distance vector. In terms of force mean this F2 vector by F2. Vector by scalar. This is magnitude of F2. In terms of the distance vector, A12 vector equal to R12 vector. Now this charge Q1 and Q2 are separated by the distance R12. What we need? Two charges Q1 and Q2. The distance between the charges R12. So based on the diagram and based on the characteristics given by the Coulombs, it is that the force is directly proportional to product of magnitude of the charges Q1 and Q2. Similarly, inversely proportional to square of the distance between the charges. So F2 is directly proportional to Q1 Q2 divided by R12 square. This is based on the X point given by the Coulombs. So while equating, we need to introduce one constant, 1 divided by 4 pi epsilon. Q1 Q2 divided by R12 square. What is this epsilon? Epsilon is the permittivity. What is permittivity? The electrical energy storage is given by the permittivity. The factor given by permittivity is nothing but electrical storage of the any medium. That is epsilon naught and epsilon r. What is epsilon naught? Absolute permittivity. That will be constant, 8.854 into 10 to the power minus 12. Epsilon r is relative permittivity. That is depends upon the medium, right? So epsilon equal to epsilon naught, epsilon r. Epsilon naught means absolute permittivity, that will be 8.854 into 10 to the power minus 12. Epsilon r is relative permittivity, that is depends upon the medium, right? Now this F2 is nothing but is a scalar form. We will take this as equation 1 in a scalar form. In order to get the vector form, we can refer the unit vector. A12 unit vector equal to F2 vector by F2. Right. So cross multiply this so that A12 unit vector into F2 equal to F2 vector. Right. So this F2 vector can be written as A12 vector into F2. Now we can get the scalar vector form, F12 equal to A12 into F2. What is this? F2 is already available in equation 1. So from equation 1 we can substitute the value F2 equal to, this is nothing but now vector. Previously what we calculated is scalar. 1 divided by 4 pi epsilon q1 q2 divided by r12 square into a12 vector. A12 unit vector. Now it is in a vector form. But a12 in another form is r12 vector by r12 in terms of distance vector. So we can replace this a12 by r12 vector by r12. So finally what we got, f2 vector equal to q1 q2 divided by 4 pi epsilon r12 cube into r12 vector. This equation number 2 is completely the vector form. Equation 1 is the scalar form. The value of epsilon, permittivity, epsilon naught into epsilon r. Epsilon naught is absolute permittivity, 8.854 into 10 to the power minus 12. This relative permittivity based on the medium will take this a free space. For free space it will be 1, right? So this 8.854 into 10 to the power minus 12 into 1. For simplification I can write it as 1 divided by 36 pi into 10 to the power 9. Both are same only. For a simplification it is given in terms of pi. 1 divided by 36 pi into 10 to the power 9. Now we'll substitute this epsilon value in the second equation, vector form. So q1 q2 divided by 4 pi epsilon r12 cube into r12 is nothing but the scale vector form, equation number 2. In this we are going to substitute this epsilon value. So q1 q2 divided by 4 pi into 1 divided by 36 pi into 10 to the power 9. This value, this epsilon value is substituted, and r12 cube into r12 vector. So this can got cancelled, 4 pi and this 36 pi. So it got 9 times. So 9 into 10 to the power 9 available in the denominator. So it will go to the numerator. So 9 into 10 to the power 9. What is, by cancelling these two, here 9 will be there. 9 into 10 to the power 9 will go to numerator. So 9 into 10 to the power 9 q1 q2 divided by r12 cube into r12 vector, right? So this is nothing but force developed on the second charge f2 in a vector form. 9 into 10 to the power 9 q1 q2 divided by r12 cube into r12 vector. That equation 1 is the scalar form, q1 q2 divided by 4 pi epsilon r12 square. That is a scalar form. So while using the problem or while solving the problem based on the vector quantity or scalar quantity, whether we can use equation 1 or this equation. This is a scalar form or vector form. This is a vector form that can be used while solving the problem. Based on the data available, either we can go for vector form or scalar form, right? Then what about the F1, first force F1? We calculate, we got the expression for F2. What about F1? Both are equal and opposite. So F1 vector equal to minus F2 vector, right? Because of both are equal and opposite, the F1 can be expressed as minus of F2. 50 microcoulomb and Q2 10 microcoulomb. Located at the point minus 1, 1, minus 3 and 3, 1, 0. Find the force on Q1, right? Two charges available, 50 microcoulomb and 10 microcoulomb at two different points. We need to find what is the force on the Q1. The diagram is available here, right? So this is Q1 at located at first point minus 1, 1, minus 3. Q2 available at second point 3, 1, 0. It can be written as x1, y1, z1. Similarly, x2, y2, z2. So this r12 is the distance between the distance vector. What is the formula for this? 9 into 10 to the power 9 q1 q2 divided by r12 cube into r12 vector. We can use the vector form because the 2 points are available. Easily we can calculate the distance vector, so that we can use the vector form, right? So 9 into 10 to the power 9, q1 q2 values are already available. Q1 is 50 microcoulomb, that is 50 into 10 to the power minus 6 coulomb. Q2 is 10 microcoulomb, that is 10 into 10 to the power minus 6 coulomb. What we need is r12 vector and r12 the magnitude. We need this r12 vector, right? So other terms are already available. How will you find this r12 vector? Distance vector. R12 vector is nothing but distance vector. distance between the 2 points, very easy. Here we have x1 y1 is z1, x2 y2 is z2. So r12 vector can be calculated as x1 minus x2, distance vector, difference between the distance, x1 minus x2 into I vector plus y1 minus y2 into j vector plus z1 minus z2 into k vector. Right, now we can substitute the value. X1 is minus 1, x2 is minus 3, y1 is 1, y2 also 1, z1 is minus 3 and z2 is 0. So minus 1 minus 3, it becomes minus 4i. 1 minus 1 0, so 0j minus 3k. Right, so finally what we have, minus 4i vector minus 3k vector. Now we got the expression for r12 vector, minus 4i vector minus 3k vector. So this is the distance vector. How will you find the magnitude? Square root of this coefficients, right? Square root of minus 4 square plus minus 3 square, that is nothing but equal to square root of 16 plus 9, that is square root of 25, it is equal to 5. Right, now we got the magnitude also. Right, the r12 vector also calculated, r12 magnitude also calculated. Now we can substitute in the formula. This f1 vector equal to 9 into 10 to the power 9 q1 q2 divided by r12 cube into r12 vector. Now we can substitute the value. 9 into 10 to the power 9, q1 is 50 into 10 to the power minus 6, q2 is 10 into 10 to the power minus 6 divided by this magnitude is 5 cube. Right, the vector is minus 4i minus 3k, j is not available, j is 0. Right, by simplifying this, what we got, 0.036, simplification of this term is 0.036. Then this vector minus 4i vector minus 3k vector, you can multiply inside, so that what we got, minus 0.144 I vector minus 0.108 k vector. Right, now we got the vector in the force F2 in a vector form, right, because the 2 points are given, so we can easily use the. Right, we'll go to the second problem. The second problem is, there is a triangle is available. At each corner of the triangle, the charges are placed. This is the first corner, second corner and third corner. In each corner, the charges are placed are equal value, 0.25 microcoulomb. Here also 0.25 microcoulomb. The distance also 0.1. It means it is a equilateral triangle. So that angle will be 60 degree. Right, at 3 corners of equilateral triangle, 3 charges are placed. The charges value are equal. The distance also equal. Due to equilateral triangle, it is 60 degree. What is the question? Determine the force on any one of the charge of the configuration shown in diagram. We need to consider one charge. For that, we need to find the force on that charge due to second and third charge. Okay. We will consider this first charge. We will see what is the force on the first charge due to second charge and third charge. Right, we will consider the first charge due to the second charge. What is the force on first charge? Due to the third charge, what is the force on first charge? Right, first we will see first and second charge. So there is a force exists between first and second charge, that is nothing but F12. F12 is the force on the first charge due to second charge. Both are available in the same line. The angle between these two is 0. So we have only one component, that is called horizontal component. Right. Next we will see the force between 1 and 3, that is F13. F13 is the force on the first charge due to third charge, F13. But first charge and third charge is placed at an angle of 60 degree. So what will happen? This F13 will be resolved into two components, horizontal component and vertical component. Right. How will you find this horizontal component? That is nothing but total component multiplied by cos of theta is horizontal component, F13 cos 60. What about vertical component? Total component multiplied by cos of theta is the vertical component. We can easily remember F13 sin 60. Right. So horizontal component is total component multiplied by cos of theta. Vertical component is total component multiplied by sin of theta. Now we have three different components available: f12, f13 sin 60, f13 cos 60. Right? These two are horizontal components. From the diagram itself, we can easily understand that f12, f13 cos theta are horizontal. This is the only vertical component, f13 cos 60. Right? Now we'll find this value one by one. The important thing is here the charges are equal, q1 equal to q2 equal to q3, that is equal to q. So that the forces also equal, f12 equal to f13, that is equal to f, because charges are equal and the distance also equal. So the force between the charges will be equal, q1 q2 divided by 4 pi epsilon r square. Right? Here we are using the scalar form. Previous problem we used the vector form, here the scalar form. q1 is 0.25 into 10 to the power minus 6, q2 also same, 0.25 10 to the power minus 6, right? 4 pi epsilon naught value is 8.854 into 10 to the power minus 12, right? The medium is not given, mean epsilon r will be 1, we will take it as a air medium, right? Then the distance is 0.1, right? 0.1 square. So what we got? 0.056 Newton, right? Whether it is horizontal or vertical component, due to equal charge and equal distance, the force between is 0.06 Newton. Right? Now we'll find the components one by one. So F12 is the force experienced by Q1 because of Q2. F13 is the force experienced by Q1 because of Q3. That already we discussed. Right. Now we'll see the horizontal component. There are two horizontal components, f12 plus f13 cos theta. Right, f12 and f3 both are equal. We can substitute 0.056 plus 0.056 into cos 60 will be 1 by 2. So it will be 0.084 Newton, horizontal component. What is vertical component? f13 sin theta, 0.056 into sin 60 is root 3 by 2. So it is 0.04849 Newton. Right. So now we got the horizontal component and vertical component. Then we can find the total force. That is nothing but square root of fh square plus fe square. Right. By substituting the value, we got 0.097 Newton. Right. So finally what we got? 0.097 Newton. Right. I will explain again. So this F12 is the force on first charge due to the second, only horizontal, there is no vertical because both are available in the same line. F13 is the force on first charge due to third, but it is available at an angle of 60 degrees, so it is resolved into horizontal component and vertical component. So that we are treated these two are horizontal, this is the vertical. We calculated this force one by one. This force value will be equal, that already calculated, 0.056. From this we can calculate the total force, 0.097 Newton. The distance and force between the charges. We can easily calculate what is the distance between the charges and what is the force between the charges. Then electric field can be calculated. That is the important thing. Electric field can be calculated from the Coulomb's law. But what are the limitations available? The law is applicable only for point charges at rest. It is applicable only for the point charges. Then inverse square law is applicable. We are using 1 divided by r12 square. Right? Similarly, charges are arbitrary shape. Right? That is normally it is a sphere. From that what we can understand what is the important point. Coulomb's law is an implication of Gauss law. From Gauss law we are deriving the Coulomb's law. The direction of force is always from positive charge to negative charge. This is a very common point, you already know. Always the force will start from positive charge and towards the negative charge. Coulomb's law employed in electrostatic, only in the static field. Coulomb is the unit of charge. Because of Coulomb's law, we are referring the charge unit of the charge as Coulomb. Right? So in this video, we discussed about the Coulomb's law, what are the characteristics and how to get the derivation expression for force, and we solved two problems. One is based on scalar, one is based on vector. Then we discussed the application, limitation and important points. Thank you for your cooperation.